In this lecture, we're going to see how we can return by reference from a function and get data on the outside. Here is a simple example we're going to use to really learn about this. And the syntax to return by reference, you take your return type and you add an ampersand symbol like you see here. This is going to mean that you want to return by reference. And the returned reference can be used to manipulate whatever data you returned in your function. This function is going to compute the maximum of two variables that we pass in here by reference. So we're going to get in and do an if A is greater than B. If A is greater than B, then A must be the maximum. We're going to return it. Notice that we are going to return the reference that was passed to us as a parameter to the function. If A is not greater than B, then B must be the maximum. We're going to return that again as a reference. And when we do that, we will be able to use the returned reference to manipulate whatever data is referenced to. And this is pretty powerful, but it can really trip you off if you are not careful. Okay, this is the definition of our max return reference function. Let's see how we can call it and some of the crazy things we can really do. Here we have the code we would run in our main function. We have two variables, A and B. The values are 15 and 13 here, and we're going to print them out. Pretty simple. After that, we're going to set up a reference variable. We are saying int reference. This is going to be a reference variable. The name is going to be refmax, and we are going to store in whatever reference is returned from max return reference, the function we just set up. And we're going to pass it two arguments, and these are going to be references to A and B like we have on top here. So it is going to compute the maximum, and it is going to return a reference to the maximum. Because this is a reference we are returning, we can really use it to modify the data that is going to be referenced. And the data referenced is the variable which happens to store a bigger value inside. In this case, it's going to be A here because it has a 15. But the beauty or something that can really be confusing about this is that we can use this to modify the data that is being referenced. And for example, here, if we increment ref max, this is going to increment whatever is storing the maximum value here, and it is going to be A. And now if we print here, A is going to be 16 and B is going to be 13. Okay, so let's note that here. And here, if we print, we're going to get a 15 for A, and we're going to get a 13 for B. And again, the big message here is that we can use our returned reference to affect the data that is being referenced. And this can be really confusing if you use this a lot in your code, but I want you to be aware of this. Another thing I want you to see is that if you set up a variable which is not a reference, and you use that to catch the return from a function that returns a reference like we have here, what you're going to have is a copy. So val is going to be a copy storing the value in the reference that is returned here, and it is going to be a 15 here. So if we print val here, we're going to see 15 printed out. Okay, so we're going to have 15 here, and we're going to have 15 here. Okay, so this is the effect of returning by reference. If you assign the return value to another reference, you can use that reference to modify the original data. And depending on your use case, this may be a good thing or a bad thing. So you really need to be careful here. One thing I want you to be careful about is references to local variables. These are going to make your life miserable. Let's look at a simple example. Here we have a simple sum function. It is returning a reference, and it is taking two parameters in by reference. But what we do inside, we set up another variable which is called result. This is a local variable to the sum function here, and we are returning a reference to it. Why are we returning a reference? Because this function here returns by reference, and if we use syntax like this to return a local variable, it is going to be a reference. Okay, this is a reference to the local variable to the sum function here. But one thing you should know is that local variables are destroyed when the function terminates or finishes executing. So if we try to use this reference to do anything with the data that is referenced, we're going to be modifying memory that doesn't belong to us anymore, because by the time we have that reference, this function will be long gone, and the memory that was storing this result variable is going to be destroyed. So it's no longer going to be ours, and if we try to use it, we're going to get undefined behavior, and really bad things might happen with undefined behavior. You might be manipulating memory that belongs to other programs or even the operating system. And sometimes the operating system is going to notice your program is really crazy. It is trying to use memory that doesn't belong to it. It is going to kill it, and you're going to get a crash. That's really bad, and you should really watch out for references to local variables and not return them from functions. This is one example where we have references to local variables returned. But if you look down here, we have the same case. We are passing our parameters here by value, and we are returning a reference here. So inside, we're going to try and find the maximum between A and B. If A is greater, we're going to return A. If B is greater, we're going to return B. But notice that A and B are passed by a value. And what we really have inside the function here are copies. Let's say AC to mean copies and BC here. These are going to be copies. When this function is called, whatever you pass in here is going to be called in the local copy, and that's what we're going to be returning here. So a reference to a local copy is bad, so we're going to be basically doing the same thing we are doing here, but it is going to be indirect because the copies here are going to be set up by the compiler. It's not going to be set up by us here. But the message is the same. Don't return references to local variables from functions. If you do that, you're going to get undefined behavior, and in most cases, your programs are even going to crash. So be sure to watch out for this. Okay, here is a simple example of how you might call these functions that return references to local variables. We can do the sum between A and B and assign the result of that to a reference, and we try to use that reference here. If we try to do that here, we're going to get a crash. And down here, you see that we are using the second function, which was passing parameters by value. So it is going to be making copies. If we return a reference to the local copy here and try to use it outside the function, when the function is done executing, we're going to get a crash if we do something like this. This is really bad. Now that you know this, we're going to head over to Visual Studio Code and actually show you this in action. Okay, here we are in our working folder. The current project is returning by reference. We're going to grab our template files like we always do. We're going to paste them in place, and we're going to open this guy in Visual Studio Code by dragging and dropping here. And we're going to open up our main CPP file. Let's do that. And we're going to clean it up a little bit, close the left pane here. The first thing we're going to do is put in a function which is going to return by reference. It is going to take two parameters in by reference, and it is going to return by reference. And we want to return by reference by appending an ampersand symbol here after our return type. And we're going to check and see if A is greater than B. If A is greater than B, we're going to return a reference to A. Again, we know that we are returning a reference by looking at the return type here. So if we use a syntax like this and say return A, we are returning a reference in C++. If B is greater, we're going to return a reference to B, and we can use these guys in the main function here. Let's go down and set up two variables. We're going to say int x is going to be 4, and we're going to say int y, it's going to be a 9, why not? And we're going to set up a reference variable. We're going to say int reference, and we're going to say ref max, and it is going to store the return value of our function call here. We're going to say max return reference, and we're going to pass in x and y. Again, these guys are being passed by references, so if we try to modify them or manipulate them anyway in the function here, we're going to be affecting the original variables here. Another thing you can do is set up a variable and say int val and assign the return value of the call to the function here. Let's do that. This is going to be valid syntax, but here we're going to be making a copy and storing again the value stored at the reference that is returned by the call to the function here. I realize this can be really confusing, but this is going to be a copy, and this is going to be a reference on the first line here. The reference here can be used to modify whichever variable stores the maximum element in here, and we're going to try and do that. But before we do that, let's try and print these guys out and really know that we have the maximum. So we're going to say stdc out. Okay, if we try and run this program, we're going to build with GCC. We're going to see that the build is good. We're going to bring up a terminal here. Let's do that. We're going to clear and run Rooster. Now we're going to see max is 9, but ref max is going to be a reference. Let's try and change these guys a little bit. Let's make x a 14 and build again and see that we really are grabbing the maximum regardless of the variable where it is living. Okay, this is really key. You should test your code to see that it is working right. Now the build is good. We can run Rooster. You see that max is 14. So we are grabbing this. But one thing I want you to see is that if you go through the reference and try to modify, actually, I think we should try and print X and Y here to show the changes. So let's do that. We're going to say stdc out and we're going to print that out. Now we're going to try and modify through the reference. We're going to say ref max plus plus to show you that we can go through this reference and modify the data referenced by ref max. So if we increment this, we expect to have whichever variable storing the maximum value to be incremented. Let's do that. We're going to actually copy what we have here and put that down below this line. And we're going to put in a simple separator so that we know this. We're going to say stdc out and put in a few lines here. I think this is going to be enough. Now try to think about what we will see when we run this program. Ref max is going to be 14 here because that's going to be the maximum. Val is going to be 14, X is going to be 14, and Y is going to be a 9. But now we are going through the reference and incrementing whatever is referenced. Remember, we got this reference through the call to the function here, which was returning a reference. So if we increment here, ref max is going to be 15 because it's going to be incremented. Val is going to be 14 because this was a copy, so it's not going to be affected by whatever we increment here. But X is going to be the variable which is storing our maximum here, so it is going to be incremented. X is going to be 15, that's what we expect here. And Y is going to still be a 9 because it won't be affected. So we're going to have a 9 here. Let's really put in what we expect. And val is going to be 14. It's not going to be affected. It's going to be whatever we had before here when we printed that out, and ref max is going to be 15. Okay, let's try and build this. We're going to use GCC. The build is going to be good. We can clear and run Rooster. We're going to have our data here. Ref max 14, val 14, x 14, y is going to be 9. And after the separator here, we're going to have ref max is going to be 15 because it has already been incremented. Val is going to be 14 because it was a copy, so it wasn't really affected by any change we do through our reference here. X is going to be incremented because it is the variable storing our maximum, and Y is not going to be affected. It is going to still store a 9. This is really the effect of returning by reference and storing the return value in a reference here. And again, depending on the design of your application, this may be a good thing or a bad thing. You're going to have to decide if you want to use this. My job here is to make you aware of this behavior here. Now that we know this, the next thing I want you to be careful about is references to local variables. So we're going to comment this code out, and we're going to go on top here and put another function in here in front of main. The function is called sum. It is going to sum up two variables, a and b, which are passed by reference, and it is going to return a reference. But notice inside, we are setting up a local variable, and it is going to store the sum of a and b. And what we are doing here, we are returning this local variable. And this is going to be returned by reference because the return type is saying so. We are returning by reference because we have an ampersand symbol appended to the return type. And returning references to local variables is really bad, because once you do this and you assign the return value to a reference, that reference is going to basically be referencing dead data. It is data that will be already wiped out by the system. And if you try to use that, you're going to get undefined behavior. Let's go down and try this out. We're going to set up two variables. One is going to be x. Why not? We can even use whatever we had before here. So let's use that. We're going to grab the code here because I don't want to type all of this. I am this lazy. So we're going to put this in. We're going to say int x and y. And we're going to say result here. Let's say result. And we're going to say sum x and y. And they are going to be passed by reference here. No big deal. We're going to say sum. And this is going to store our sum. But we are returning a reference to a local variable which is already dead by the time this function returns and gives us the result. So if we try to use this reference to do anything, we don't really know what we will be manipulating in memory. And in most cases, on my system, I have been getting crashes by running this code here. Let's go down and try to use this reference. We're going to go down and say stdc out and say result, and we're going to do result here. And hopefully Visual Studio Code is even going to give us a warning. It isn't. This is really bad. So we're going to try and compile this code. It is going to compile, and you see that we get a warning from the compiler. The compiler is saying you are returning a reference to a local variable. And this is really bad. If you try to run your program, anything might happen. Okay, we got a warning, but the build finished successfully and we have a binary we can run. So we can clear and run a Rooster now, and you see that we get a crash. You see that result is, and the program actually crashed. And the operating system is basically saying, this guy is trying to use memory that doesn't belong to him. I'm not going to allow him to do that. I am going to kill him. And you see that the program was actually killed by the system a few seconds after we run it. Let's try and run it again. We're going to say Rooster, and you're going to see, the operating system is going to try to print this guy out. But it is going to see that it is bad memory that we are trying to access, and we're going to crash our program. Why do we crash, and why is this bad? When the program crashes like this, anything after this line is not going to run, and we might have really important code after this line here. Let's go down and say that to really show you the crash. So we're going to say done here, and you're going to see that this line here is not going to be run and print done. Let's build again. I really want you to see this. So the build is finished, but we have a warning, and we're going to ignore the warning because we want to see our crash. We're going to run the program. You're going to see that we're not going to say done here. The program is basically going to be killed by the system the moment this line here executes. This is really bad, and you should avoid returning references to local variables like we are doing here. You see Visual Studio Code is even warning us about this. Reference to local variable result returned. This is really bad. You shouldn't do this. Okay, so this is one case where we might have a reference to a local variable returned. And this is direct. You can see that you are setting up a local variable and you might be really careful in not returning it. But sometimes things aren't this obvious. And I am going to show you another example. Let's go down and put in another function. The function is called max input by value. It is going to take two parameters by value, but it is going to return a reference. Because we are passing parameters by value here, these guys are going to be copied. So A and B inside the function are local copies that are constrained to the scope of this function here. So they are local copies and we are returning them. And if we do this, we're going to get the same problem we had here. But it is not obvious that these guys are copies because you think, these are parameters that are passed to the function. So they must be not local to the function, but they are passed by value. And the compiler is going to make copies of whatever arguments you pass in here. And it is going to store copies in these two variables, which are local to this function here. So if we go down and set up another example, let's really use the same code here. Are we using integers? Let's go back. Yes, we are using integers. We can use this. So we're going to go down and use that function here. And we're going to say max input by value. We're going to copy the name of this function. And that's what we're going to use here. And in this case, x and y are going to be passed by a value here. And we're going to be basically having copies of these guys in the body of this function. and we're going to be returning a reference to either A or B, which are local to the function. And if we try to use this result like we did on top here, let's do that. We're going to copy this and use that here. We're going to get the same problem. We're going to get a crash because this is a reference to a variable which was local to the function here. And by the time we store the result of this function in this variable here, the function is long dead. And the memory we are referencing here doesn't belong to us anymore. And if we try to access it like we are trying to do here, we're going to get a pretty bad crash. Let's do that. We're going to build with GCC and we're going to get the same warnings. Reference to local variable returned. The compiler is really helpful here, but if we ignore the warnings, you see that the build finished with warnings. The build was finished. We had our binary generated, but we have warnings. The compiler is telling us that we are doing a really bad thing. We shouldn't use references to local variables. But we are stubborn and we're going to try and run our program here. We are basically going to be modifying memory or trying to access memory that doesn't belong to us. The operating system is going to say, this program is crazy, I am going to kill it. And it is going to be killed at this line here when it tries to access bad memory. And anything after this line is not going to execute. We're not going to see the done line here printed out. This is really all I wanted to share with you about returning by references. If you have safe references you can return from your function, that's going to be fine. For example, max return by reference here is safe because the references don't belong to the scope of this function. They are just passed parameters to the function and we can return them if this makes sense for our application. But references to local variables are really bad and you should avoid them in your application. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can return by pointer and do similar stuff to what we did in this lecture. Go ahead and finish up here and meet me there.